Hello, dear students. Today we have to discuss position time graph. So this one is the graphical representation of one-dimensional motion. So here you have to take position along one axis and time along another axis. A particle in motion occupies different positions at a different instant of time. That is, its position coordinates varies with time. A graph of position coordinate against time gives the graphical representation of motion. It is called position time graph. It can be used to analyze different aspects of motion of particle. A graph of x versus t called xt graph. X means position, t means time. Okay. Xt graph is a characteristic of the nature of motion executed by the particle. See, in this graph, one axis is time axis, another axis is position axis, that is x. Here x means position. So the positions are 20, 40, so like that. So initially means at t equal to 0, the position of an object is at 40. After 10 seconds, its position is 40. After 20 seconds is also the position is same. So by joining all the points, we are getting a straight line which is parallel to time axis. So this graph represents the particle is not changing their position. Okay, it's called rest. The particle is, or that object is, or the body is at rest. Means position is not changing. Is it clear? Okay. Now see this graph. So at t equal to 0, the position is 0, hence the point is at the origin. Go on increasing the time, the corresponding position also changes, and mark the points, and by joining this we are getting a straight line. So from this we can say position is changing means the particle is moving or motion, and by equal interval of time the change in position is also same. For example, at t equal to 0, the position is 0. At t equal to 2, position is 5. T equal to 4, the position is 10. T equal to 6, the position is 15. So like that. So what it means, for every interval of time, the change in position is same. So then we can say it is uniform motion or uniform velocity, and it is positive velocity. Is it clear? Note on the points. Let us to continue next graph. See, in this graph, the time x is 2, 4, 6, etc. and the position 0, 50, 100, so on. The graph is not a straight line. Clear? So what it means? There is unequal changes in equal interval of time. Cleared? So this motion is called a non-uniform motion and the velocity is called non-uniform velocity. If the question asks what is non-uniform velocity or non-uniform motion, means if an object moving along a straight line covers unequal distances in equal interval of time, it is said to be non-uniform motion along a straight line. This graph shows non-uniform motion. Is it clear? Draw the graph and note on the points. Go for next graph. See, this graph is also straight line. But what happens? The initial position is more and the position is decreasing, means x value is decreasing here as the time changes. So it means we are getting negative slope. Okay, but the motion is uniform, remember, because the graph is, if the xt graph is straight line, the motion is uniform, but here the slope is negative. So this uniform motion is negative or negative velocity. We can say it is negative velocity. Cleared? Okay. So now by knowing position time graph, that is xt graph, and uniform and non-uniform velocities. Okay, let us to discuss average velocity. What is this average velocity? The term average velocity means, so change in position by change in time from initial to final position. That gives the total displacement divided by time taken, and this total displacement by time taken itself is the average velocity. Average velocity. See the relation, the average velocity v bar equal to x2 minus x1 divided by t2 minus t1. So x2 minus x1 is change in position, we can write it as delta x, t2 minus t1 as delta t. Okay. So where x2 and x1 are the positions of object at t2 and t1. Okay, and this bar over the symbol v or over the symbol for velocity is standard notation used to indicate an average quantity. And the SI unit of velocity, whatever may be the velocity, okay, so it is measured in terms of meter per second in SI. Okay, we can write m bar s or m small s s to the power minus 1. You can read it as meter per second, and it is a vector quantity. Vector quantity means it is having a particular direction. Any physical quantity having particular direction, we can say it is vector quantity. So now we have to discuss the average speed. Simply speed means distance by time, velocity means displacement by time. So average speed means the total path length or the total distance traveled divided by total time taken to complete that path is called average speed. See, that average speed is total path length divided by time taken. Okay, time taken is total path length divided by time taken. The SI unit for speed is same, meter per second, but it is a scalar quantity. It is not having any particular direction. Is it clear? Okay. Now there are some important note. If the motion of an object along a straight line and in the same direction, the magnitude of displacement equal to the total path length. In this case, the magnitude of distance and displacements are same, so average velocity is equal to the average speed. If the particle is moving in a straight line with same direction, if you measure the velocity and speed, both will get same. Remember, if a body moves for half time with speed v1 and for other half time with speed v2, then the average speed we can calculate it as v1 plus v2 whole divided by 2, that is average, v average equal to. And one more important thing, if the body covers half of the distance with speed v1 and other half of the distance with speed v2, then the average speed of the body is given by v average equal to 2 v1 v2 divided by v1 plus v2. Okay, note that v average equal to 2 v1 v2 divided by v1 plus v2. Okay, one more term, instantaneous velocity. The term instantaneous means at particular instant of time. If the velocity of a body is non-uniform, then its velocity at any instant is given by the ratio of distance delta s covers in small interval of time delta t. So it means at what particular time, if you want to measure the velocity, so in that time you take very small interval of time, and during that small interval of time, how much the change in position, that is displacement, you have to measure it, and by taking the ratio of in short interval of time how much displacement and that time interval, the ratio itself gives the instantaneous velocity, means that particular instant of time. So this instantaneous velocity is given by limit delta t tends to 0, delta x by delta t, and delta x by delta t gives dx by dt, dx divided by dt. Okay, so this is about the velocity, that is average velocity, instantaneous velocity, okay, average speed. Okay, so in next class let us to discuss velocity time graph, that is VT graph. So today we have already discussed about XT graph, means position time graph, and here velocity time graph. Okay, thank you.